Okay, we'll look at the homework problems in section 14.5 that deals with the surface area. And in this case here, we're going to look at problem number 1, where you're going to find the surface area of figures on the right. And we'll look at the one at the top. The one is called, this is a rectangular prism, a right rectangular prism to be exact. Here the length is 14 centimeters, the width is 4 centimeters, and the height is 9 centimeters. So to find the surface area of this right rectangular prism, now this is the formula that I like to use. In this case, the surface area, I'm labeling this as SA, is equal to 2 times the length times the width plus 2 times the width times the height plus 2 times the length times the height. Okay? And the reason for that is this. 2 times the length times the width is this. You got the length times the width, and you got 2 of them, one on the top and one on the bottom. That covers the surface area on the top and the bottom. 2 times the width times the height, that covers the 2 faces on the right and on the left. And then length times height. So the length, this is your length, this is your height. That covers the surface area or the faces on the front and the back. Okay. So in this case here, the length is 14, the width is going to be 4, and the height is 9. And they're all in centimeters. So we're going to have 2 times the length, which is 14, times the width, which is 4, plus 2 times the width, which is 4, times the height, which is 9. So I have 2 times 4 times 9, plus 2 times the length and the height. The length is 14 and the height is 9. So it'll be 2 times 14 times 9. So in this case here, we're going to go ahead and multiply this out. And I'll go ahead and put the units at the end when I'm finished with this problem. So here, 2 times 14 times 4 is 112, plus 2 times 4 times 9, that's going to give me 72, plus 2 times 14 times 9, that will give me 252. So if we add 250, well, if we add 112 plus 72 plus 252, you're going to get 436. So the surface area is 436 square centimeters. 436 square centimeters. That's going to be the surface area for this right rectangular prism. Okay, the next one is the right circular cylinder. And in this case, its surface area is going to be this particular formula. And this is in your textbook. 2 pi times the radius square plus 2 pi times the radius times the height. Okay, the 2 pi r squared is this. That's the sum. That's the 2 bases here. Both bases are circles, so you have pi times the radius squared for the area of one circle, but you got 2 circles, so that's why it's 2 pi r squared. And then that 2 pi rh represents the lateral surface area. Okay, because if you were to cut out the cylinder to make it flat, then you'll have pi r, well, actually you'll have 2 pi r for the length, and then the height will be that width. Okay, so now the radius here is 4 centimeters, the height is 14 centimeters. So here's what we're going to have. And we're going to leave our answer in terms of pi. So it'll be 2 pi times the radius, which was 4. So that's 2 pi times 4 to the second, plus 2 pi times the radius, which is, again, 4, times the height, which is 14. Okay, so now let's simplify this. 4 squared, or 4 times 4, is 16. And 16 times this 2 is going to be 32. So now you got 32 pi plus 2 times 4 is 8. 8 times 14 is 112. So now you have 112 pi plus 32 pi. Add those two together, you're going to get 144 pi. And this will be in square centimeters because area is always in square units. So the surface area of that right circular cylinder would be 144 pi square centimeters. Okay, now let's look at the next problem. All right, in this case here, two cubes have sides of length 7 centimeters and 5 centimeters. What is the ratio of their respective surface areas? Okay, so here, in this particular case, we want the surface area of the first cube. So let's say the first cube, and the surface area of any cube is going to be 6e to the second. E represents the edge of that particular cube. And the first cube is 7 centimeters. So here we're going to have 6 times 7 to the second. And 6 times, well, 7 to the second is 49. And then we're going to do 49 times 6. That's 294. And that's going to be 294 square centimeters. That's the surface area of that first cube. And then the second cube has the edge of 5 centimeters. So its surface area is still going to be 6e to the second, which means 6 times the edge is 5, and that'll be 5 squared. Now 5 squared is 25, so now you're going to have 6 times 25, which will be 150. And that's 150 square centimeters. So the surface area of that second cube with the edge of 5 centimeters will be 150 square centimeters. Now we want their respective surface areas having that ratio. So we're going to take the ratio of the first cube to the second cube. Okay, so the ratio there will be, in fraction form, 294 over 150. Okay. Now we can reduce this. So 294 over 150 in simplest form will be 49 over 25. Here we divide the numerator and the denominator by 6. Now, they probably want you to write this as 49 with the colon 25 as a ratio, 49 to 25. Okay, so that's how we do the second problem. Okay, now let's look at the third one. It's a soup can. It has a 4 5/8 inch diameter and is 5 inches tall. What is the area of the paper that will be used to make the label of the can if the paper covers the entire lateral surface area? And you want to use 3.14159 for pi. Okay, let me give you an illustration. Okay, and I'm going to use something like this. This is almost like a can. It's this outer paper right here that we want to find out what that area is going to be, and that's the lateral surface area here. Okay, so, and we're dealing with a soup can, which is similar to a right circular cylinder. So normally the surface area is always going to be 2 pi r squared plus 2 pi times r times h. That's the surface area. However, this 2 pi r h represents the lateral surface area. That's the one we want. That's your lateral surface area. The 2 pi r squared represents the area of the two bases, the top and the bottom. So here, the lateral surface area is simply 2 pi times r times h. Okay, now let's look at what we're given. The diameter is 4 5/8 inches. Now I'm going to convert 4 5/8 inches to a decimal. That will be 4.625. And the way I got that, the 4 is your whole number, so do 5 divided by 8, you'll get the decimal part, 0.625. So it'll be 4.625 as the decimal equivalent for 4 5/8, which is your diameter. This formula calls for the radius. So here, the radius is just simply 1/2 the diameter, or 1/2 of 4.625. So if you take 1/2 of 4.625, you're going to get 2.3125. So that's your radius. And the height that was given to us was 5 inches in this problem. So here, the height is 5 inches. Okay, so here, we're going to use that formula here. So our lateral surface area is going to be 2 times, now we're told to use 3.14159 for pi, times the radius, which is 2.3125, times the height, which is 5 inches. And our lateral surface area is going to be in square inches, so if we do 2 times 3.14159 times 2.3125 times 5. Now, if we round this off to 2 decimal places, as indicated in the directions, your lateral surface area will be 72.65. And that's going to be in square inches. So the lateral surface area for this particular soup can, which is going to be the area of the paper that will be used to make the label on that can, will be 72.65 square inches. Okay. All right, let's look at problem number 4. If a cardboard tube of a toilet paper roll has a diameter of 2.94 inches and is 6 inches tall, what is the lateral surface area of the cardboard roll? So you have to think of a roll of toilet paper, and you want that lateral surface area, just that roll, which is in the form of a cardboard. That's the lateral surface area. That's what you want to find. So if you recall with that last problem, that lateral surface area was simply 2 pi r times h. Okay. Now the diameter is 2.94. We want the radius, which is 1/2 of 2.94. So take 1/2 of 2.94, you're going to get 1.47. So the radius is 1.47 inches. And the height is given to us as 6 inches. Okay. So in this case here, we'll use that formula there. So the lateral surface area is equal to 2 times. Now we're going to leave our answer in terms of pi, so we just bring down the pi. So you have 2 pi times r, that's 1.47, times the height, which is 6. Okay, so we know we got 2 times 1.47 times 6. And that will be the number in front of pi, which is 17.64 pi. And that unit will be in square inches, because area is always in square units. So the lateral surface area for this cardboard tube of toilet paper will be 17.64 pi square inches. Okay. And finally, let's suppose one right cylinder, called cylinder A, has a radius of 3 meters and height 5 meters, and another called cylinder B has radius 5 meters and a height 3 meters. And this we want to answer in 2 parts. Which cylinder has the greatest lateral surface area, and which cylinder has the greatest total surface area? Okay, so now in this case here, we're going to look at cylinder A and cylinder B and find the lateral surface areas for each one of those. Okay, so let's look at cylinder A. The lateral surface area, that formula is 2 pi r times h, if you recall. Now in cylinder A, your radius was 3 meters and the height was 5 meters. Okay, so let's use this formula. Just replace those values here. Bring over the 2 pi, then the radius is 3, the height is 5. So you have 2 pi times 3 times 5. Well, 2 times 3 is 6. 6 times 5 is 30. So that lateral surface area is 30 pi square meters. Okay, so that's cylinder A. Now cylinder B is this. We have the radius of 5 meters and the height of 3 meters. So now your lateral surface area is still 2 pi r times h. So now you have 2 pi times the radius, this time is 5, and the height is 3. So now 2 times 5 is 10, 10 times 3 is 30. So it's 30 pi square meters. Okay. So if you compare those two, you will see that those lateral surface areas are exactly the same. So in this case here, we will choose answer A, that they both have the same lateral surface area. Okay, now part B, which cylinder has the greatest total surface area? Okay, so here, the total surface area is 2 pi r squared plus 2 pi RH. Okay, so let's start with cylinder A. Okay, that surface area there, we're going to do 2 pi times the radius, which is 3. So it'll be 2 pi times 3 squared plus 2 pi RH is this number right here, 30 pi. Now simplify this. 3 squared is 9. 9 times the 2 is 18. So now you have 18 pi plus 30 pi. Add those two together, you're going to get 48 pi square meters. So that's the surface area for cylinder A, the total surface area. Now we want the total surface area for cylinder B. Okay, so we use this formula, but here we're going to do 2 pi times, now the radius is 5. So it'll be 2 pi times 5 squared plus 2 pi RH, that's just 30 pi. Okay, now 5 squared is 25. 25 times that 2 is 50 pi. Well, 25 times 2 pi is 50 pi. Plus that 30 pi. Add those two together, you're going to get 80 pi. And that's in square meters. Okay, now compare the total surface area for cylinder A with the total surface area of cylinder B. You can see here that cylinder B has a greater total surface area. Okay, so we would choose this answer. Okay, that one, cylinder B has the greater surface area than the total surface area in cylinder A. Okay, so that should assist you with some of the homework problems in section 14.4.